Hi everyone, welcome to walkthrough of my project Enterprise AI Architecture for Supply Chain Intelligence. I'm Ganesh, and in this session I'll walk you through how the system has been designed from the ground up, what problems it solves, how the architecture works, and how AI transforms supply chain operations end to end. So this isn't just a concept. This is a practical enterprise-ready framework that ties together AI, automation, and cloud infrastructure. When I say AI architecture, I mean the system-level design that integrates multiple intelligent layers: data ingestion, machine learning, event orchestration, and decision automation. I built this keeping in mind the real-world supply chain challenges, visibility, risk prediction, and optimization across multiple regions and systems. Over the next few slides, I'll explain how this architecture works in reality. We'll go through each layer, how data moves, how intelligence is generated, and how the system ensures resilience and transparency. So think of this as a deep dive from data to decision, all within a live enterprise ecosystem. Let's get started. All right, let's pause here for a second and really look at what's happening in most enterprises today. See, the headline says it all. Today's supply chain suffer from a reactive decision reflex. In other words, we are always responding after the fire starts instead of predicting it ahead of time. See this. This messy knot of pipes represents what's going on inside large organization. You have ERP, logistics, and finance systems all moving data separately, each one optimized for its own function, but none of them actually connected. Data goes in circles here. Decisions takes too long, and the result is operational friction. See this. This silos create blind spots. When your ERP updates inventory, logistics might still be planning shipments based on yesterday's data. Finance can't see real-time cost or exposure. So every time something changes, a port delay, a supplier issue, people are stuck coordinating manually. Predictive intelligence. What we want is to untangle this mess and push everything towards predictive intelligence. Here you can see a continuous data flow that feeds AI models and return real-time insights. This is the entire transformation we are aiming for in this architecture. See, manual planning and disconnected systems. That's the daily firefighting. Teams scramble through Excel sheets and email threads, wasting hours just to align. Every minor disruption triggers what we call micro crisis management. This operational data trapped in silos, ERP, logistic, finance, each speak their own language. Without a unified data backbone, you can't generate a holistic view of demand, supply, or cost. Most AI projects isolated experiments, and this is a big one. Many companies pilot AI tools but never scale them because there is no governance layer, no feedback loop, and no integration into actual business workflow. Over 70% of AI projects in supply chain post-pilot fail. That static is brutal but true. So if you think about it, this slide sets the stage for why our enterprise and architecture matters. We are not just building another AI dashboard. We are constructing the nervous system that connects ERP, logistics, and finance into one intelligent organism capable of acting before problems occur. This arrow is the transition point from chaos to clarity. And in this slide, we all see these things. Now we will go to the next slide and I will show you the vision of how this predictive intelligence actually manifests across systems, different enterprise ecosystems. Now that we've seen how reactive and tangled today's supply chains are, this slide is all about the vision, where we are heading. See this. That phrase, governed autonomy, is important. It means we are not chasing full automation for the sake of it. We are building trustworthy autonomy AI systems that act intelligently but within enterprise governance and control. See this. Let's start here. This is the world we live in today. You can see the keywords: fragmented, manual, opaque, and isolated. Each one represents a real-world pain point. First, fragmented data and systems. Every function, whether it's procurement, logistics, or finance, runs on separate databases and applications. That fragmentation creates data silos that makes end-to-end visibility almost impossible. Second, planning is still largely manual. Planners rely on spreadsheets or outdated dashboards that refresh once a day. Far too slow for a dynamic supply network. This third, decisions happen in black boxes. People don't see how those decisions are made. And even when AI is used, there is no transparency or audit trail. That's risky in enterprise environments. And finally, most AI projects are isolated, proof of concept pilots that never make it to production. They lack integration and feedback loops, so they fail to deliver sustained business value. See, this arrow right here represents the transformation journey. It's the bridge between chaos and intelligence, between reaction and prediction. And that's exactly where our architecture comes in, to operationalize this journey. On this side, we are seeing the target vision. Step 1 is a unified data fabric, a connected data foundation that stitches ERP, logistic, finance, and external data into one real-time context. It's the backbone of our architecture, a single version of truth that every model and decision can trust. Once the foundation exists, AI can finally do its job, predicting demand shifts, optimizing routes, and reallocating resources before problems occur. But we are not building a black box here. We are enforcing governance through policy-driven orchestration. That means every decision is explainable, logged, and follows enterprise policies automatically. Finally, this is the holy grail, a closed loop learning system. Every decision's outcome feeds back into the data fabric. So the models keep learning, getting sharper, faster, and more aligned with the real world performance. Because of the feedback we are getting, is that decision was right, wrong, what was that? So it will help to learn. All together, these pillars form what we call governed autonomy, a state where the enterprise runs intelligently, continuous learning, but still under complete human and policy control. This is the vision our entire architecture delivers. And in the next slide, I'll show you how it's technically built from the ground up. Now, this slide right here is the core blueprint, the heart of how the entire supply chain intelligence system operates. When you are looking at here, is not just a technical diagram, it's the operational backbone of an intelligent enterprise. It connects real-time data to decisions, continuously, autonomously, and with governance built in at every step. The data layer is where everything begins. ERP feeds, logistics systems, finance transactions, IoT sensors, and third-party data all converge here. This layer is all about collecting and organizing data in a consistent, trusted format, essentially building a single version of truth. Without this layer, everything else falls apart. Once the data is unified, it flows into the AI layer, this layer. This is where predictive models, optimization engines, and anomaly detectors live. The goal here isn't just analytics, it's intelligence that understands context and anticipates outcomes. For example, AI might predict that a shipment delay will cause a stock out downstream and suggest an alternative fulfillment route. Now, this layer is where the magic happens, orchestration. Think of this as the conductor of the symphony. It takes insights from AI layer, from this layer, and converts them into actions, automatically triggering workflows, sending alerts, or even updating systems like ERPs or WMS, warehouse management system. The orchestration ensures timing, dependencies, and business policies are all followed perfectly. Finally, we have the execution layer. This is where the rubber meets the road. This is where automated actions happen. Shipments get rerouted, inventory levels get adjusted, or purchase orders are issued. Everything about this layer is about thinking, and this layer is about doing. Now this is the end-to-end production architecture. This slide connects every moving part we've talked about so far, data, AI orchestration, and feedback, into one real-world system that runs 24/7. Let's go step by step from left to right, because that's how data flows through this ecosystem. Everything starts here with real-time data signals. You have got your ERP, WMS, and TMS systems sending operational data. IoT sensor gives you your shipment or temperature signals, and market feed like weather or supplier APIs updating in real time. These are your eyes and ears of the enterprise, the raw truth from the field. Once these streams come in, they land here in the data lakehouse layer, powered by tools like Kafka, here we have Spark or Databricks. This layer standardizes, cleans, and structures the data so it can flow smoothly into AI systems. Features stores like Feast or Great Expectations manage the reusable features for your models, ensuring consistency between training and inference. Notice this layer. Thus, this governance strip running vertically along the edge. It ensures every data transformation, every model, every deployment meets enterprise grade standards. ML flow handles model versioning, vault or IAM manager, uh, IAM managed secrets, and audit logs keep track of every model decision. That's how we build trust in automation. Now comes to this orange box. This central core is the brain of the architecture where all intelligence is generated. Inside it, you have got three main engines working in sync. This forecasting engine, optimization engine, and decision intelligence. First, the forecasting engine. This predicts demand, lead times, and disruptions using models like LSTM, Prophet, or traditional time series approaches. Next, this optimization engine. This uses methods like MDPs, MILP, or graph-based heuristics to find the best solution. For example, optimal shipment routes or resource allocation. Now comes to this layer. Finally, the decision intelligence layer. This is where reasoning meets prediction. LLMs, RAG-based systems interpret model outputs, summarize decision briefs, and make recommendations human can actually understand. So instead of raw numbers, you get clear narratives. Reroute shipment X to port Y to avoid a 36-hour delay. All together, these engines from a closed AI core combining analytical power with explainability. Once a decision is ready, it passes to the orchestration layer, powered by LangGraph or temporal. These orchestrators coordinate actions across systems, making sure AI decisions trigger real workflow in the right sequence with policy checks. The open policy agent enforces compliance. For example, blocking a shipment reroute if it violates a regional trade restrictions. We also include human in the loop checkpoint. This ensures sensitive or high impact actions still get human review before automation executes them. Operational execution and learning loop. This loop I'm talking about. This is where decisions actually execute. The ERP, TMS, WMS systems receives AI-driven updates, orders, schedules, or allocations. The digital twin system runs simulations in parallel, testing what would happen if conditions change. KPI and dashboards here track everything: accuracy, turnaround time, and cost impact. Feedback loop. And this feedback loop, we close the loop. Every decision outcomes, good or bad, flows back as a new data here into the lakehouse. That feedback retrains models, update policies, improves future decisions automatically. So in the essence, data enters from the left, intelligence is created in the middle, decisions are orchestrated in the right here, and learning comes full circle at the bottom. That is where what we call operational AI at enterprise scale. A system that's self-learning, policy aware, and production grade. It's not a lab prototype. It's a live architecture designed for continuous autonomous improvement. Now this slide takes us right into the AI core, the part of the architecture that actually thinks of the enterprise. Up to now, we have seen how data flows through the system. But this is where that data turns into intelligence, insights, forecasts, and optimized decisions. You can see here, leverages advanced machine learning, optimization to predict demand, simulate scenarios, and generate actionable intelligence. That's the mission of this layer. It doesn't just report what's happening, it anticipates what will happen next and tell us what to do about it. So let's go through these three key components that makes this layer work. The how behind the intelligence. First, the forecasting engine. This uses deep learning models like LSTM, TFT, and Prophet to predict demand patterns, lead times, and supply fluctuations. Think of this as the crystal ball of the supply chain. It continuously learns from sales, logistics, and external signals to tell us what's coming next week or even next quarter. For example, it might forecast a spike in the demand in Southeast Asia due to an upcoming festival or predict a port delayed based on historical congestion data. Optimization engine. Next, we have the optimization engine, which is the problem solver. Once forecasts are in, the engines use mathematical optimization techniques like MILP. This is a mixed integer linear programming, RL, reinforcement learning, and OR tools to find the best possible solution, maybe the most efficient shipment route, the best resource allocation, or how to minimize cost while keeping service levels high. And the final layer, this is the decision intelligence. And the final piece, decision intelligence, this is where the AI becomes contextually aware. It uses LLM and RAG, retrieval augmented generation, to understand the bigger picture. It doesn't just crunch numbers. It explains them. So instead of giving you a spreadsheet full of predictions, it gives you a narrative based on forecasted demand and port delays. Reallocating 20% of shipments to route B will reduce lead time by 15%, like this. That's the decision support in natural language driven by live data. So all these three together, these three engines work like a loop. The forecast engine predicts, the optimization engines recommends, and the decision intelligence layer translates those into actionable, explainable insights. So here, capability, and here is the why. This is the why. This layer transforms raw data into predictive insights and optimal decisions. It shifts supply chain management from being reactive, what's just happened, to proactive. Here is what's about to happen, and here is what we should do. So here we can see. So if you look at this small flow on the side, this AI layer sits right at the center of the value chain, connecting data at the bottom to orchestrate an execution at the top. It's the intelligence bridge that keeps the enterprise one step ahead of disruption. In short, this layer turns information into foresight and foresight into decisions. That's how modern supply chain evolved, from reactive chaos to intelligent autonomy. Now let's talk about the real brain of this entire system, the multimodal AI layer. I call this multimodal because it combines multiple kinds of intelligence: deep learning, optimization algorithm, large language models, all working together under governance to create truly explainable and actionable decisions. Notice here, this layer sits right in the middle of the full architecture. It's where data gets transformed into decisions. The feedback loop keeps it learning continuously. So how does this brain actually works? Let's unpack it piece by piece. So this component uses deep learning models like LSTM. You can see here LSTM TFT Prophet for high accuracy predictions, both for demand forecasting and delay predictions. Think of it as the system sense of foresight. It continuously scans real-time data from ERP sensors and market source to anticipate shifts in demand or disruption before they happen. These models don't just run once, they retrain periodically, improving accuracy as more feedback comes in from operations. Optimization engine. Then comes the optimization engine, which takes the forecast and figure out what to do about them. It uses mixed integer linear programming, MILP, reinforcement learning, and even Google or OR tools to solve complex resource allocation and routing problems. For example, if the forecast engine predicts a shipment delay, this optimization layer will automatically simulate scenarios, adjusting routes, prioritizing suppliers, or reallocating inventory to minimize impact. It's not just AI making guesses. It's mathematical precision, ensuring that every decision is cost and efficiency optimized. Decision intelligence layer. This is where we bring in LLMs and RAG pipelines, turning raw model outputs into human understandable, policy aware insights. Think of it like this: the forecasting and optimization layers produce the numbers, but this layer produces the story. It explains those results in clear business language. For example, shipment delays in region A will impact 12% of orders. Rerouting via port B will reduce cost by 8%. These summaries help supply chain managers act fast without needing to dig through technical dashboards. Governance. And here is the most critical part: governance. Every model, every decision is managed through ML flows. Here we are using ML flow, ensuring lineage, version control, and auditability. That means you can always trace which model made which decision, on what data, and why. This is the crucial for enterprise environments where explainability and compliance are not non-negotiable. All these components, four components. So when you combine all four, forecasting, optimization, decision intelligence, and governance, you get a truly multi-model AI system that not only predicts and optimizes, but also explains and defends its decisions. Capability unlocked. Why? And this is the outcome, the why. This layer moves beyond simple predictions. It delivers actionable, optimized, and defensible decisions that enterprise can trust. And remember, the more decisions it makes, the smarter it gets. That feedback loop, this feedback loop retains models, updates parameters, and improves scenario reasoning, all under governance. In short, this layer is the brain that connects machine precision with human reasoning, predicting, optimizing, and explaining every move that enterprise makes. Now that we've seen how the AI layer makes intelligent predictions and optimizations, the next question is, who actually carries out those decisions? This layer right here is what I call the conductor. It's like the maestro of an orchestra, ensuring every AI insights turns into a well-structured, policy-compliant operational workflow. As you can see, this sits right between AI layer, this AI layer and the execution layer, the bridge between intelligence and action. The key word here is policy-driven orchestration, meaning automation doesn't run wild. It's guided by business rules, regulations, and human oversight where needed. So let's break down how this conductor works. There are three major components driving this layer, all these three. Workflow orchestration. First, we use tools like LangGraph, Temporal to structure AI decisions into multi-step resilient workflows instead of firing off single isolated actions. This layer coordinates complex sequences like forecasting demands, optimizing allocations, then pushing the decisions into ERP or TMS, all automatically and in the right order. These orchestrators are event driven, meaning they react in a real time. Every new data signal, every prediction updates can trigger the next best action without human delay. Yeah, move to this next one, policy enforcement. The second piece is policy enforcement, handled by Open Policy Agent, OPA. This is critical. OPA acts as the guardian of the enterprise AI operations. It ensures every action follows compliance and regulatory compliance. For example, if a model tries to reroute a shipment through a restricted region or make a financial decision above a certain threshold, OPA will intercept and block it in real time. This gives enterprises full trust that AI decisions stay within defined boundaries. Finally, human in the loop. Because even the best AI, some decisions require human judgment. This layer adds approval gateways for critical or high impact actions. That means before an automated decision executed, like cancelling a supplier contract or adjusting key pricing, it pauses for human review. So here, all three together, these three components, orchestration, enforcement, and human oversight, form a closed, auditable loop that keeps AI automation intelligent but controlled. Capability unlocked. And this is the why behind this layer. It ensures every AI-driven action is transparent, compliant, and aligned with the enterprise policy. So while the AI layer gives us intelligence, this orchestration layer gives us integrity. It makes sure that the right things happen for the right reasons and that humans always stay in the loop where it matters most. This AI is the brain, but this is the nervous the AI is the brain, but this is the nervous system that makes thought into motion safely, consistently, and compliantly. And in the next layer, we'll see how all of these translates into a real operational execution and learning on the ground. All right, now we have reached the final layer, the executor. This is where everything we have built, data, AI, orchestration, and governance actually comes to life inside real enterprise systems. See this one, this is the layer. You can see here, this sits right below orchestration. This is the action layer. It takes orchestrated AI decisions and executes them across systems like ERP, TMS or WMS, then tracks how those actions perform. The key here is in the phrase closing the loop. This closing the loop. It's not enough for AI to make a decision. The system needs to learn what happened after that decision, success, failure, or deviation, and feed it back. So let's break this down step by step. System integration. First, system integration. This is where decisions get pushed into real systems through direct API based execution. For example, a routing optimization output from the AI core can automatically update shipment routes inside SAP ERP or a transport management system like Oracle. TMS, no manual touch needed. This tight integration ensures intelligence translates instantly into operational actions. Second point, this is the pre-flight validation. Before an AI decision goes live, we validate it in a digital twin. This is the digital twin environment where a virtual replica of the supply chain we create. This allows us to simulate outcomes. What would happen if we reroute, reschedule, or reprioritize certain shipments and catch risks before they impact real operations? It's like a pre-launch checklist for AI decisions. Now comes to the next one. Performance monitoring. Every executed action is tracked in real time by KPI collector that feeds dashboards showing operational metrics, lead times, fulfillment rates, cost savings, model accuracy, etc. So if a model's decision doesn't yield the expected result, we can spot it immediately and adjust. And finally, the feedback loop. This is the system's self-improvement mechanism. It captures the outcome data from real-world execution, what worked, what didn't, and feeds it back into the AI layer for retraining. This is what keeps the architecture alive and evolving. So every circle from prediction to action to learning makes the system smarter, faster, and more efficient over time. And here is why this layer matters. It creates a self-improving system, one that not only automates decisions but learns from them. Every decision strengthens the next one. So at this point, what we have is a full closed loop AI system. Data feeds intelligence, intelligence drives action, and action fuels learning. That's the hallmark of a truly autonomous enterprise. And from here, we can start looking at the system's monitoring and observability, how we ensure it runs reliably and safely at scale. Now, what you are seeing here is what turns our AI engine from a cool prototype into a trusted enterprise-grade system. This slide shows the proactive framework that wraps around the entire architecture, ensuring it's secure, auditable, and production ready. At the core, you have still got your data, AI orchestration and execution layer, but now they are encircled by two key support systems: governance and MLOps on one side and security and deployment on the other. Let's break those down. Move. This is the left side we are going to explain first. Governance and MLOps ensures that all your models and automation process remains trustworthy and well controlled throughout their life cycle. You can see this. We use ML flow here for complete model lifecycle management, from versioning and deployment to auditability. This means every model decision is fully traceable. You can see what version of the model was used, what data it was trained on, and what decision it made. Performance monitoring. For monitoring, we integrate Grafana and Evidently AI. These continuously track model drift, data anomalies, and performance degradation in real time. If an AI model starts deviating or losing accuracy, alerts are triggered immediately. So governance isn't reactive, it's proactive. Now comes to the third point. Then CI/CD automation with GitHub Actions and Terraforms. Every model and service deployment becomes repeatable, version controlled, and secure. No manual code drops. It's fully automated, policy checked pipeline. And so in essence, this pillars ensures discipline and traceability. No rogue models, no unmanaged workflows. Now comes to the right side. Over here, you can see this. We focus on resilience and security at scale. Infrastructure. Kubernetes based modular microservices we are using here. The architecture runs on Kubernetes based modular microservices, which means every friction, data ingestion, AI inference, orchestration runs independently but communicates seamlessly. That makes the system resilient and highly scalable. One module can scale up without affecting the rest. Next, it's cloud agnostic, deployable across AWS, Azure, or GCP. This is huge for enterprise flexibility, no vendor lock-in. The same blueprint can run in hybrid or multi-cloud environments depending on compliance needs. Now comes to this one. And finally, security. This is where enterprise confidence comes from. We integrate Vault for secret management and IAM for access control and RBAC, etc., ensuring that every token, credentials, and API key is protected. Comprehensive audit logging means that every action, whether by a human or a model, is recorded and traceable. Notice these feedback loops. Notice these feedback loops wrapping around. These aren't just aesthetic, they symbolize the continuous governance cycle. Every operational insight feeds back into MLOps, and every model update goes through security validation before redeployment. So all these framework is what makes the entire system enterprise grade. It's not just intelligent, it's secure, compliant, and scalable by design. This is how you take an AI idea from the lab to global enterprise operations responsibly, safely, and confidently. All right, now let's see this architecture in action. Driven port and supply chain optimization. This is where theory meets reality. What you are seeing here is a real world implementation of systems like what I'm showing in the global maritime supply chain, which is one of the most complex and data rich ecosystem in the world. The problem here is universal port congestion, manual scheduling, and siloed systems. Ships are delayed, cranes are underutilized, the idle times translate directly into cost and carbon emissions. So here how our architecture tackles that. First, sense. We start by pulling real-time data, AI vessel signals, weather forecasts, and IoT feeds, all streamed through Kafka. That's our live sensory layer feeding the data fabric. Next, predict and optimize. We use models like TFT, RL, reinforcement learning, to predict estimated time arrival, ETA, and optimize crane and berth scheduling. The goal here is to minimize vessel idle time. Every minute a ship waits is fuel and money wasted. Then decide. This is where LLM, LangGraph, and OPA comes in. They generate governed decision flows, ensuring every automated action complies with operational policy, port authority rules, and safety regulations. Finally, act. We use temporal workflows that continuously update. API every 5 minutes, real-time orchestration in production. This ensures schedules and port operations stay synchronized with live conditions. We are synchronized with actual real-time conditions. Here we are predicting, deciding, and acting. That's the closed loop in motion. Sensing, predicting, deciding, and acting continuously, autonomously, and safely. See here, outcomes verified benchmarks. Now let's talk about outcomes. This is where stakeholders lean in. Plus 10 to 15% vessel throughputs at Port Exchange Rotterdam 2023, meaning more ships processed per day with the same infrastructure. 20 to 25% idle time reduced at 𝗔𝗂𝘁𝗫 Smart Port Pilot 2022. Massive gains in operational efficiency. 10 to 12% lower fuel consumption achieved through optimized routing verified by Maersk AI Routing Data 2023. And most importantly, an 8 to 11% reduction in CO2 emissions validated through the Maersk Sustainability Report 2023 and Real Sustainability Impact. These aren't projections, they are verified benchmarked matrices. Now comes to the strategic impact. Let's put this in the business term, profitability. We are seeing saving of $3.34 million per quarter purely from reduced idle time. Sustainability. This aligns directly with IMO 2025 and Maersk 2040 decarbonization goals. Scalability. See this. The architecture is containerized and replicable, meaning once it's proven in one port, it can be deployed across others with minimal customization. Viability. It's already integrated with TOS ERP systems, making it ready for production grade rollout. So what you are looking at here isn't a concept slide. It's evidence that this architecture delivers measurable ROI, sustainability impact, and operational resilience at scale. And the best part, every improvement here came from the same feedback-driven intelligence loop we built into the architecture. The system isn't just automating operations, it's learning from them. Now everything we have covered from sensing to orchestration comes down to one ultimate question: what's the business impact? Because at the end of the day, architecture is only as good as measurable value it creates. Let's start with some cross-industry benchmarks to give context on what similar AI-driven systems are achieving globally. Plus 25 to 40% improvement in forecast accuracy, reported by McKinsey in 2022. That's the difference between reactive logistics and predictive operations. 15 to 30% reduction in logistics cost, according to Gartner 2023, driven by AI-based optimization automation. 20 to 30% higher delivery reliability, validated by BCG 2023, as AI helps synchronize real-time supply and demand signals. These are the benchmarks, and our architecture is built to match and exceed them. Now, here is what separates the system from the many AI pilots that never scale. First, it is a complete end-to-end architecture connecting real-time data, ML forecasting, reinforcement learning, and Gen AI driven decisioning. See, it's not a patchwork of tools, it's an integrated ecosystem designed for production workloads. Second, you can see it's governed and auditable. Every model, every workflow is controlled via OPA, monitored with evidently AI, and deployed through automated CI/CD pipeline. That means it's not just smart, it's responsibly smarter. And third, it's continuously learning. With temporal based feedback loops, the system doesn't just automate decisions, it improves them with every iteration. That's the leap from AI assistant to AI autonomy. It is totally different from AI assistance to AI autonomy because of all these things. So when we say from pilot to production, this is exactly what we mean. Proven AI and Gen AI architectures delivering measurable, auditable, and sustainable optimization. From a business perspective, this transforms AI from an experiment into a competitive advantage. So when an executive asks, what's the ROI of this system? It's not theoretical. You can point to forecast accuracy, cost reduction, reliability, sustainability, and scalability. All proven matrices that directly tie back to the architecture you have built. This slide is essentially the proof that architecture isn't just IT. The architecture isn't just it's strategy. Before we step into the future vision of this architecture, I want to pause for a moment, because this slide represents the core philosophy behind everything we have been building. Amplifying human expertise, not replacing it. This architecture, this entire AI system isn't designed to replace people. It's designed to amplify them. Think about that. AI doesn't replace leadership, judgment, or creativity. It simply clears the noise, the manual triage, the repetitive data checks, the endless low-value analysis. That's why human can focus on high-value work, strategy, innovation, and complex problem solving. By automating low-value cognitive works, we can concentrate on high-level works. This is where the impact starts. By automating low-level cognitive work, pattern matching, report generation, repetitive reviews, AI gives leaders back their time to think. It lets them lead creativity, negotiate better, and build smarter strategies instead of getting stuck in operational clutter. Come to the second point. And that's what defines a future-ready enterprise. Not the one with the biggest AI stack, but the one that can balance automation with the human ethics and oversight. The real differentiator isn't more technology. It's the harmony between human intuition and machine precision. Those who master that balance will lead industries, not follow them. Now come to the last point. It's absolutely crucial: transparency. This system doesn't make black box decisions. It provides clear, natural language justification. You can ask why a decision was made, and the system explains it in a plain English language. That's how trust is built, not through complexity but through clarity. When executives can query an AI and understand its reasoning, they collaborate with it. They don't compete with it. It becomes a partner, not a mystery. So we think, see all points. If we think of the entire enterprise AI journey, this is the human foundation. AI shouldn't replace decision makers. It should empower them to think bigger, faster, and more strategically. This is the bridge between where we are now and where we are heading next. A future where intelligent systems and human expertise evolve together. Let's take a look at what the future actually looks like, where these systems evolve into fully autonomous ethical decision ecosystem. Now, before we wrap up, let's talk about where this architecture is heading. This is where let me take marker. This is where everything we have built so far is leading. A future where intelligent operations are not just automated, but ethically aligned, self-learning, and deeply integrated across the entire value chain. The first is cross-enterprise. This is the first point. Cross-enterprise orchestration, extending AI-driven decision intelligence beyond the walls of one organization. Imagine real-time coordination between global suppliers, logistic partners, and distributors, all sharing insights through secure APIs. It's true network level optimization, where the entire ecosystem operates as one synchronized unit. Now comes to this point. Automated ESG compliance. Here sustainability metrics become parts of the decision logic itself. For example, the system can automatically weight environmental impact, emissions, or energy efficiency before finalizing an optimized decision. This is how we move from profit-driven AI to purpose-aligned AI, operational intelligence that supports both business goals and sustainability mandates. Now comes to the last point. Finally, the LLM governed agent networks. This is the frontier, multi-agent AI systems that can negotiate, plan, and execute operations autonomously. Picture AI agents representing different enterprise domains: procurement, logistics, finance, communicating and collaborating in natural language to resolve conflicts or optimize outcomes in real time. All 3 points together, these advancements form a fully autonomous decision ecosystem, scalable, explainable, and ethically grounded. This isn't science fiction. It's the logical next step of everything we have built here today. And that brings us to the final message. Everything you have seen, the architecture, the orchestration, the governance, this isn't a lab experiment or a proof of concept. This is production grade. This is a real production grade system already capable of running in live enterprise environments. Its blueprint for bringing AI from experimentation to governed real-world impact. This architecture has every layer an enterprise demands: governance and security, continuous learning and policy compliance, full scalability across multi-cloud environments. So when people talk about AI being future tech, this system proves that the future is already here. It just needs to be deployed responsibly. Intelligent responsibly. And this is the principle stand by. Let's not just build intelligent systems. Let's architect them responsibly. Systems that are transparent, explainable, and amplify human expertise. That's the difference between hype and impact. And that's what enterprise AI should stand for. Thank you. And of course, here are all the references and frameworks that informed this architecture: open, credited, and aligned with Creative Commons standards. Thank you.